All right, in this video we're going to take a look at what the second derivative of a function tells us about the shape of its graph. So, I already know what the first derivative tells me about f. I know that if f prime is positive, that f is increasing. And I know that if f prime is negative, that f is decreasing. Okay? And I'm even going to put an implication arrow here. If this is true for f prime, then this is true for f. Okay. What I want to do is see what I know about f double prime. Okay. So I'm going to start with some information about f double prime. Now f double prime is the first derivative of f prime. So the relationship between f double prime and f prime is the same as the relationship that we have up here. If f double prime is positive, that's going to force f prime to be increasing. Okay. And if f double prime is negative, then the derivative of f prime is negative, and so f prime is decreasing. But what I'd like to do is see if I can't translate that even further to see what it tells me about the graph of f. Okay. And it's tempting to say that this has to do with the graph getting steeper or less steep. But it's not quite that simple because I need to remember that derivatives are signed quantities. So I'm going to just take a look at two cases. I'm going to consider that f double prime is positive, so it's going to be bigger than 0. And I'm going to look at f prime also being positive. I'm going to just draw what that graph might look like. So if the derivative is positive, my function has to be going up. So here I'm going to be sketching an f of x that satisfies these conditions. So it's got to be going up, okay? And the second derivative has to be positive, so the first derivative has to be increasing. So I'd be going from a positive number to a bigger positive number. So it's going to have to look something like so that the slope of the tangent line is increasing. And that does mean that we are getting steeper. But let's consider case 2. Let's suppose that the second derivative is positive, but the first derivative is negative. So now we're going to have a graph that's going down. Now if I made my graph get steeper the way this one does, we'd be going from a small negative number to a bigger negative number. In that case, the first derivative is actually decreasing. It's going down. Okay. And I wanted the first derivative to be increasing. So with negative numbers, I have to remember that as negative numbers increase, their absolute value actually gets smaller. Okay. So down here where values are negative, if I go from -5 to -1, that's increasing. Okay. But the absolute value of -1 is smaller than the absolute value of 5. So if I've got something where the first derivative is negative, so I'm going down, but the first derivative is increasing, that's going to mean that it's becoming less negative. So we're going to be going down, but actually getting less steep. Okay. If we think about it, if we think way back to when we were graphing x and we were trying to graph f prime of x, and we were talking about what that told us about the shape of f. Remember how we sort of had two steep zones? Okay. So if f prime was positive and increasing, we're moving towards the steep zone, f would be getting steeper. But if f prime is negative and increasing, it's moving away from the steep zone, it's getting less steep. Okay. So our graph would look like this. Okay. Now, if I sort of put those two pieces together, I get this smiley face-like thing. Okay. We say that when we have a shape like that, we call that concave up. Okay. So f would be concave up. Basically, it looks like all or part of that graph. That's concave up, the the whole thing is concave up. If it were raining, this would be how you could collect water. Okay. A more formal definition of it is that if it's concave up, you'll notice that the tangent line lies below the curve. So if the second derivative is positive, the original function is going to be concave up, so that the graph will look like all or part of this, depending on whether f prime is positive or negative, so whether I'm decreasing or increasing. Okay. So if f prime is negative, that means f prime is decreasing. Let's look at the two possibilities. Case 1, f double prime of x is negative, but f prime of x is positive. So f would be going up, but decreasing. So we're going to be going from a bigger positive number to a smaller positive number. So something like this. That means we're going from a big positive slope, which would be steep, to a smaller positive slope, which is less steep. Case 2, f double prime of x is negative, and f prime of x is also negative. So when I graph f, I know we've got to be decreasing, but the derivative also has to be decreasing, which means it's going to get more negative. So going from a small negative number to a bigger negative number for the slope. And so in that case, it's getting steeper. So it's not enough to simply say, oh, it's getting steeper or less steep. We've got to describe instead the concavity. And if I put these pieces together, we get something that looks like this. So if the second derivative is negative, the graph of f is going to look like all or part of that graph. We say that that is concave down. And a more formal definition of that, if you'll notice, if it's concave down, the tangent line always lies above the curve. All right. So, I'm going to give you a problem to work on. F of x is going to be 5x to the 2/3 minus 2x to the 1/3. Okay. And I want you to find me the intervals on which f is increasing and decreasing. I want you to find me any and all relative maxes and mins. So the location and value of the relative extrema. Okay. And then I want you to find me the intervals on which it's concave up and concave down. Okay. Now for these will always be open intervals. And that's because when the concavity changes, I can see the concavity changes right around there. When the concavity changes, the tangent line crosses the curve. So on the part where it's concave up, the tangent line is concave down, the tangent line is above the curve. On the portion where it's concave up, the tangent line is below the curve. At the point where it changes, it's neither. So these guys will always be open intervals. And then I also want you to find me the points of inflection. Now, before I define that, I'm going to just emphasize that it's points. Point means there's an x and a y value. A point of inflection is just a point where the concavity changes. Okay, so there's your task. Give that a shot. We will go over this together in the next video.